All right, so our next speaker is Matthew Berninger. He's going to be talking about doing some machine learning on some Twitter stuff.
All right, can you guys hear me pretty good? I'm not as tall as Phil, but I still get to use the mic. All right, yeah, so my name is Matt Berninger, and this is TweetSeeker. I have a slide at the end, but TweetSeeker is actually an app you can buy on the Apple Store. I found that. Probably should have researched that before I submitted the talk name. It's not my app, but anyway, I'll probably be changing the name. Last year, I presented AP Tinder, and then that changed its name, so it seems like if I present it, I'm going to change the name of the model. So anyway, here we go. So this is TweetSeeker extracting adversary methods from the Twitterverse, a.k.a. over-sciencing a social media problem. So a little bit about myself. I'm a former SOC analyst and incident responder. I used to work for US CERT. I'm currently a data scientist on the FireEye Advanced Practices team, and I'll go into what that team does and why it's relevant. I'm originally from the DC area, currently rooting for the Nationals. Who gets that joke? Anyway, rooting for them in the World Series this week. Pretty exciting. And relevant to this discussion, I apparently, according to Reuters, have a social media problem. That's a picture of me in 2012 in Idaho National Labs during a cybersecurity exercise. It has absolutely nothing to do with Twitter or social media. Pretty sure I was responding to an email or playing Brick Breaker. Probably Brick Breaker. But anyway, in 2012, Reuters ran an article about Homeland Security, where I worked, watching Twitter and social media. FYI, Homeland Security watches open source Twitter and social media, like the rest of the internet. Anyway, they used that article, or they used that picture for the article, so I'm infamous forever. Thank you, Reuters. That was pre-beard. So I work on the advanced practices team, and the advanced practices team at FireEye. We do a couple things, but one of our missions is adversary methods, and our job is to apply knowledge of attacker tradecraft to capture actionable signals. It's our internal mission statement. What that really means is we want to know what the bad guys and girls are doing, and we want especially to know the new things they're doing, the advanced stuff, the stuff that we're not detecting, the stuff we're missing. We want to be on that cutting edge of adversary techniques and procedures. So as a researcher on the advanced practices team, we get exposed to a lot of this information through our incident response activities. If you've heard of Mandiant, that Mandiant division of FireEye does a lot of IR, and as a result of those activities, we get a lot of information about what attackers are doing, naturally. We also get a lot of device telemetry, signals that come from our devices, endpoint, network, et cetera. But as much as we like to use those two sources, I got to admit, we get a lot of good stuff from the InfoSec community. It's a great community, obviously, and conferences and other talks and various different ways of finding stuff out, we oftentimes get a lot of ideas and research concepts from the community. So we have really pretty well-defined technical means of ingesting information from the red boxes, but we didn't really have like a defined way of ingesting information from the InfoSec community. It's all sort of like network, right? Just like talking to people. So I thought, well, why don't we do that? So the objectives of this talk are, I'm going to define the problem. We're going to explain a framework, sort of a fun little toy model framework that we put together. It involves some tweet classification methods, some network discovery models. Then we're going to put it all together, and I'll get into questions at the end. Disclaimer, before I start knocking on tweets here. InfoSec Twitter is amazing for many reasons. It's great camaraderie. It's a great community. I'm a member of the InfoSec Twitter community. And so I just want to be clear that this research is focused on a very specific use case. And just because the classifier might score something low doesn't mean that it's a bad tweet or that the user has bad tweet content. So I think all of the not useful stuff is stuff that I've tweeted. So I was trying to use my own stuff, but not trying to knock on anyone's feed here. All right, so who here knows what Squibbly-Doo is? Got one. All right, so Squibbly-Doo is an arbitrarily named application or app locker bypass that was tweeted out by Subt, a researcher named Casey Smith, who's based out of Colorado. Really smart guy. And he tweeted out basically this. The tweet has since disappeared from the internet, but he tweeted out this line, reg server 32. If you can't see that in the back, it's reg server 32, and then some arguments, and then a network address and a DLL. And this was tweeted out as an app locker bypass, and at the time, this would bypass Windows app locker. You could use reg server 32 to pull down an SCT file and execute arbitrary code, do bad things with it. This kind of like was crazy, right? And he had a link to this blog post. This blog post is still up on the Internet Archive. This is April 19th, 2016. So I remember when this happened, because I'll tell you a story. This is me and my coworkers being super chic in our super cool cyber center, as all InfoSec analysts do. They're cool beards. And like all cyber analysts, we're just, checking Twitter, working hard. And the tweet comes across the internet, we see it, and we're like, oh man, we should probably write a detection for that. So we did. You don't really need to read that, it's an HXIOC. But anyway, we wrote some logic wrote a regex essentially for those arguments. There's some things you can do in that command line to make it a little bit different, obfuscate it. So we try to get around that and write a regex for it. We push that indicator out to devices that we have visibility on, try and find evidence of this technique being used. And sure enough, we found a whole bunch of hacked boxes. And this is actually, just quick note, it's a really good example of, like sort of red team disclosure helping us find something we wouldn't have otherwise found, because when we poked at that, we were actually able to uncover a nation state actor that was using this technique. And we put together a report on APT32, which is a Vietnamese-based actor. We put that report out in 2017. So this was months of work that went into this, but it really started from that initial tweet. So that initial awareness came from Twitter. And as much as I have a love-hate relationship with social media, I had to admit, having gone through this, man, that was actually a really useful information source. And we wouldn't have started this process if it wasn't for that initial thread. So this really woke me up to the potential power of Twitter as a sort of InfoSec awareness tool. That being said, the problem with Twitter is that it's not built for InfoSec information sharing. It's built for dopamine consumption or addiction. And so Twitter is built to keep me scrolling, keep me clicking, keep me engaged. It's not built to give me good endpoint IOCs and get me on my laptop to write logic. So I wanted to get all this amazing stuff. This is from the last couple weeks or months. It's happening right now. There's amazing indicators going out, lots of people sharing research. It's great. All these amazing people doing this amazing work. I wanted all that stuff that I get without the stuff that I probably spend too much time on. Me tweeting about decaf coffee, Bill James, if you're a baseball stats guy, I don't know what he's talking about now. Obviously, We Rate Dogs is the best thing on Twitter, but I spend too much time on that. So I wanted actionable stuff without that stuff. The problem is, so I thought, okay, let's use the Twitter API, and selfishly, I also wanted to learn more about social network analysis. The kind of stuff that Phil does is really cool. So it was just like, I want to learn about this. So I got into the Twitter API. However, if you've worked with the Twitter API, you can't just download all of Twitter. I haven't figured out a way. And you can stream, there's little ways around it, but I couldn't retroactively say, give me all of Twitter and I'm gonna find all the good InfoSec stuff. So I kind of need to know who to follow and which of their tweets to read, and this is where we're getting into the model. So what I needed was a tweet rating model and a network discovery model. So here are my diagrams of that. So a model that ingests a tweet and predicts the usefulness as we define it on our team, and a model that intakes a network. Luckily, we'll be talking about graphs. I know no one's really mentioned it at this conference yet, but we'll be getting into graph theory. And the discovery model will kick out some potential users to follow. And both of these models are relatively simple compared to stuff being presented here. So we'll start talking about the classifier first, because I kind of need the weak or initial classifier to bootstrap the discovery process, and I'll show you how that works. So we start with a list of initial sources, and this literally, when I started, was literally just the handles of the advanced practices team at FireEye, pretty Twitter active. And so I started with let's just start with the 4 or 5 of us and see what happens. Pull a bunch of tweets, pull a bunch of people we follow, kind of just ask the team for people they follow. So that is, every time that you see the hourglass, it's the API. That's me sort of like pressing enter on my laptop while my dogs bark. And going out to Twitter, getting those tweets. And then kindly ask my advanced practices colleagues to label tweets. We ended up labeling 2,000 tweets. It was quite laborious. Thank you very much to my teammates for doing that. And then we have some labeled data. So not a large labeled data set, but then we were able to sort of train a weak or initial classifier on that labeled data set. So how did we label it? We ended up labeling into 6 categories, just because there were so many different definitions of usefulness that we ended up kind of getting granular. And so one is what we call samples. A lot of people sharing samples, files, MD5 hashes, virus total links, domains, etc. These are relatively easy to spot, right? You see that and you're like, okay, someone sharing a sample. I'm not telling a story about decaf coffee there. Red team exploits, this is like the Reg Server 32 or Scooby-Doo bypass would have fit into this category. This is somebody saying, here's how you do something. Oftentimes these have screenshots, so that comes into play. Then there's blue team. So blue team's like defender stuff. So a lot of people share like ERA rules or detection ideas or hunting ideas in this way. So that's sort of the blue team category. You have intel, where someone's talking about an emerging campaign. There's an APT29 phishing campaign many months ago where it was kind of blown up on Twitter, and a lot of people found out about it that way. So that's yet another sort of style of information we ingest. Tools and tutorials is starting to get a little bit more general, and it's still useful, but just less specific. These people sharing, hey, something like String Sifter, for example. Hey, check out String Sifter. It's an awesome tool. Super useful. I'm not going to write an IOC necessarily, but I may use it. And then other. And I originally called this thought leadership, but yeah, I thought that might not be great. So anyway, we're calling it other. This is the kind of market differentiating knowledge that you can expect from my Twitter account. That's not useful. It's not going to help me, it's not going to help me find bad guys. So we wanted to remove that stuff. So tried out a couple different labeling policies, and I'm not going to go too much into, I can answer questions about it later, but we essentially decided on policy 2 here. But what I want to highlight here is sort of this spectrum. Over on the sample side, you may remember there was a lot of hashtags and sort of like not natural language, right? Artifacts and indicators over here. These are super simple and actionable. I can take those IOCs, I can immediately add them to a threat intel feed, I can look for domains, etc. Sort of in the middle, you have sort of cyber jargon, stuff like command line arguments, but people using, and actually this model is entirely based in English, so people using English words to describe things, starting to get closer to natural language, it's still a lot of jargony. And then as you get over to me talking about coffee and stuff, it's just natural language nonsense. So from an NLP perspective, just keep that in mind that you're not dealing with natural language, so to speak, on the artifacts and indicators side. And I should mention, so we just used policy 2. Everything left of policy 2 is sort of like something we can act on pretty quickly. And everything to the right, while there is useful stuff there, was a little bit too general and frankly harder to separate those classes. So we ended up kind of drawing down the middle there. All right, so the features we fed into the classifier, I won't go too much into this. Kind of the stuff you would expect if you read a blog on tweet classification, sentiment analysis, you'll find this stuff. Statistical stuff like the length, the number of the words, entropy. Interesting metadata like is it a retweet, is it a quote, is it a reply, the number of quotes. I'll go in quickly onto some part of speech tagging. We did number of links and a lot of stuff you can get out of the Twitter API. It's a very rich data source. There's user information that actually ended up being far more useful than I expected. You can find stuff like, this is me, my followers and my friends. Friends are people you follow. Listed count, I just want to highlight that. Who knows what a Twitter list is? Yeah, so I didn't know what that was, and I was like, is that the verified, is that the check mark? No, a list is when somebody adds you to a filtered list, which is a much simpler way of solving the problem I'm talking about. It's just making a list of people like, hey, these are InfoSec people. I just want to check that list. So if you're on a list, the number of lists that you are on shows up there, and that ended up being a pretty useful feature. Number of favorites, number of people have liked, mine's pretty low, and then number of statuses. The reactions is the tweet, how many people liked it, how many people retweeted it. It's really hard to do replies. You can do this, but it requires more API calls to figure out replies because of sort of the tree branches that come off of threads, so it's hard to figure that out. But if you ever heard about the Twitter ratio, that's what this is based on. The problem with the reactions was that you have to wait for those reactions to come through, so you couldn't necessarily classify squibbly-doo the time it's tweeted. You'd have to wait for someone to react to it, then use those features. So I wanted to use features before reaction so we could sort of be more in line. I want to highlight some work done by Evan Wright on the FireEye team. He's done some awesome work on a sort of an adjacent problem, trying to find software vulnerabilities. There is a blog. It's super awesome. You should check it out. Very advanced, far more advanced than what I'm talking about. But it's basically looking for the severity of software vulnerabilities using named entity recognition and part-of-speech tagging. Evan was kind enough to help me out with some part-of-speech tagging of the tweets. So this is kind of what it looks like. I won't go too much into it, but if you know about part-of-speech tagging, this is basically nouns, et cetera, parts of speech here. And then the part-of-speech tagging that this Evan's model does, or this paper's model does, is sort of Twitter-specific, so it does stuff like links and other sort of Twitter entities like hashtags, which are helpful. This was a good way of generalizing some of the words that show up in tweets instead of TF-IDFing and sort of kind of a nice dimensionality reduction way to keep my features down because I only had 2,000 samples, so I didn't want to get too wide in the feature space. Anyway, we were able to use some of that. Just quickly going over the fun feature findings. Number of hashtags was highly correlated or helped separate things in policy 2. And then you see the proper nouns there also helping. Don't want to spend too much time on this slide if you have questions. So here's the classifier performance. Pretty decent, I'd say. Trying gradient boosting and just sort of surveying a couple of these, getting about 80, 81 under the curve there. And then here's the precision recall curve. So we end up going gradient boosting here. And so it's not a great classifier, but it's good enough for our use case. So now we're getting to discovery models. And starting with sources, I want to then go out to the Twitter API, get all their followers, build a network graph of people that the sources are connected to. Then use some network centrality measures to find other potential sources in that network. Now that I have my sort of weak labeling model or my weak classification model, I can then go grab tweets from those potential sources saying, hey, this is maybe somebody I should follow, pump their tweets through the model, then select the best users according to some metric, and then add those sources to my initial source list and sort of cycle through this and continue to build up my network of people I want to follow. So that's why we wanted the classifier first. So I needed to have a network to start with, and thankfully DerbyCon, which is a big blue hat conference, this is their final year, they published all their speakers on a Google sheet on the internet, and all of the Twitter handles are there. So I thought, wow, that's a pretty good community to just use randomly that isn't super biased in my opinion. So I was like, okay, I'll just grab that and sort of play with that. So built out a network according to followers and friends, retweets, so pulling all their tweets down, or the last, I think it was last 1,000 tweets, and then building out their follower and friends, and then who they quoted. So these, my obligatory graph visualizations. And the objective was to find that small set of users worth investigating in those networks, and the approach was to build those networks and use the centrality measures, as I mentioned. So what we did was, I go over this again, really belabor this point, build the network, then calculate the top 10 users with that chosen metric, and we surveyed a couple. Pull the last 200 tweets from each user, feed that through the prediction model, and then calculate the timeline metrics to say basically which approach, which centrality measure gets me the highest score of my top 10. So a bit arbitrary, some decisions in there that we might tweak with, but basically use, PageRank, for example, to give me the top 10. Let me grab those top 10. And if that outscores between this centrality, then I'll use PageRank to find my new users. So ran a bunch of experiments, and here's all your different centrality measures. And basically, we compared it against just randomly selecting users out of the network and pulling their tweets. So it was effective, more effective than just randomly pulling people out of people's Twitter networks. So between the centrality ended up being, I think, in aggregate, the best here. This is the following network, the retweeted network, and the quoted network. Also experimenting with a weighted graph where I combine all three of those, but haven't done that yet. And then I actually created a different score. So to be clear, this is just the average of the classifier score over their last 200 tweets. You'll notice that the average score is really low. That's because even people who share a lot of useful stuff, they're still replying and retweeting and sort of engaging in conversations. So they're not always dropping fire all the time. Now, what I wanted to do was get an actionable tweet likelihood. That's the number of statuses per day. So what's your volume, and then how dense is your volume with useful stuff. So the percent of useful statuses above a certain classifier score times the number of things you tweet per day. So this is the expected value of how likely is sub T to be tweeting squibbly-doo on a given day. And this helps optimize for my team's use case. So this metric was more informative, and you can see a little bit better separation there between the different experiments. So let's put it all together. So using that I just described, we're going to keep iterating. We've been doing this for a while, keep iterating and building out our network. And our network is, I think, about three times maybe more larger than when we started. So we actually have a really large network of people to follow. And it's actually sort of helped my Twitter life, just adding people to my followers or people I follow. But the model now has sort of iterated a couple times around, and we've added a bunch of people. Then we actually go out and grab, we put it in line, grab those users, pump them through the initial scoring model, and serve it up to the team via API. So above a certain threshold, we say, hey, this is 0.2 or whatever above. Here's 5 tweets that our team should check out today. Here's some samples that we should probably model out. Here's maybe some IOCs we want to write. Maybe here's an APT investigation we want to check out. The nice thing about that is, as we evaluate that, I can get feedback from my team as they action them and turn that into labeled data which I can then use to retrain the model and improve it. Because just like Phil's problem, we're kind of label starved in this space. Asking your friends to manually go through an Excel spreadsheet of 2,000 tweets, many of which are the negative case, me not tweeting useful stuff, is a tall order. So this way I can use our operations to label our data and go back and retrain it. And then just continue repeating that continuously. So this is a big sort of Rube Goldberg machine we've got in place now, and lots of Python and duct tape here. But essentially, we're going to keep iterating this, and it's been providing useful tweets for our team to review, and hopefully gets them off of Twitter, the native application. So operations and impact, again, this is us in the SOC being super cool. We're ingesting and analyzing those samples, so those IOCs, those network domains, et cetera. We're building signatures and IOCs off of stuff like Squibbly-Doo and other app locker bypasses, et cetera. And then we're starting big research projects, and we see those sort of like big ideas, like, hey, maybe use this data source, and a lot of ideas that might come out of this conference, for example. We would start a much longer-term research project. But again, that initial thread can come from Twitter. And then, of course, we're using those labels to go and improve the model. Of course, while I was doing this research, somebody else beat me to the punch. This Twitter, of course, I found out about this on Twitter. This person tweeted out, I want to say 2 or 3 weeks ago, awesome researcher tweeted out tweetioc.com. So this scrapes Twitter for that sample class, right? So that first class that was just samples, domains, MD5 hashes, et cetera, sort of regex for that. It's pulling that out. The one thing I have noticed, this is super awesome, and I totally plan to use this to improve my model. Some of those domains are just going to be regular domains pointing to something else. So you can't just like blanket ingest this stuff and start blocking IPs. I wouldn't recommend that. But this is a fantastic store of information to even actually do, user. It's really Nick. That's my boss, to do user sort of discovery. And also, as I mentioned at the beginning, the name TweetSeeker is taken. It's only $5 on the App Store. So some lessons learned and next steps. If you're just going to pull down all the tweets, is like what I started doing. Going more than 2 degrees out is an expensive thing to get into. If you ever tried that, give it a shot. Plug in your computer, and you won't need to heat your house for a while. There's a ton of information in the Twitter API, and to be honest, I haven't exploited all of it. There's still more to explore there, and it's been a really fun journey just checking it out. Next steps, obviously, we want a larger labeled data set, so that feedback loop is going to help us improve our model. I definitely have some ideas from Phil's talk, the weak labeling approach, and semi-supervised approaches. There's this interesting ratio thing I discovered where thought leadership, the ratio of favorites to retweets, now this is using those reaction metrics, but this might be a nice little retroactive labeling function that we can talk about. Thought leadership had a substantially higher ratio than the other 5 classes, and that's precisely what I was trying to separate, right? And I should have removed that, that's other, sorry. Thought leadership was higher, so that might be a labeling function we could incorporate. Multi-class classification, obviously, because we have those 6 classes. And then the other idea is like, a lot of times some red teamer will just tweet something like oops, and it'll be a link to a blog post. It's really hard to model that out, and it'll be their exploit. It's hard to model oops. Or it could be something else that they oopsed about. It's not useful. So following the links and building features off of those linked pages could be something. Go a little bit deeper and add more context there. So a lot more to do here, but it's been a fun little project. The tools I used, the Twitter API, obviously Tweetbee is a great package, help me with that. Standard stuff, Jupyter Notebooks, NetworkX, we've talked about that. I used Cytoscape Graph UI to make those amazing graph visualizations you saw earlier, so check that out. It was easier than my coding, which is not great for visualization. And then my acknowledgements here. Thanks to Evan, Nick Carr, and Christopher Glyer, my coworkers. Thanks to Casey Smith for that first tweet that sort of gave me this idea, and for all the work he does. Hex Waxwing started a project called the Leet List, which is a list of InfoSec users that also was sort of instrumental in building up this concept. And then my wife, who listens to me talk about Twitter and talk about this for a while. So thanks to all those folks. And with that, I'll take any questions.
Thanks for an interesting use of Twitter. So it justifies looking at it at work, so that's great. So I was wondering, were you doing anything when you were taking the the high scores from your model and getting feedback from those and then feeding them back in. Are you doing anything like active learning to make sure that you're not just reinforcing your model, like just learning on what you already think is good, but like folding it in a principled way?
Yeah, I'm not sure. I don't think I'm doing that because we're predicting stuff we haven't trained on, right? So then,
right, but you had a prediction.
Oh, sure.
That you were ranking stuff with, and then you were looking at the high scores from that, and then you were labeling that and feeding them back in. Like you got to be careful so you don't just reinforce your biases.
Yeah, I think that's something that we definitely need to watch out for. Like that, I mean, that would be what's happening right now. On the other hand, we have a lot of other tweets that come in through other channels that people are bringing in and saying like it'll just show up in chat.
Okay, so
like,
you do have a source of novelty. So you
exactly,
don't,
and when they so this actually all goes into a chat room. And when they drop it in chat, I will grab that tweet and say, well, clearly this was useful because someone just shared it with the team. And so that's sort of an independent signal that I can use to add to that data set. But good question. Or tweet at me with questions.
It's definitely an interesting talk. So I know this is a security conference, but every time when you were talking about it, I just kept thinking about financial sector because I know they're using models to kind of do similar stuff with the trades, right? So some news breaks, and you have the trading algorithms that automatically make these decisions. And so I was curious, were you able to find work in that space to kind of bring over, or is there? I was just curious if you thought about that.
That's a great question. I can't say that I encountered any of that. Maybe when I first started. Just checking out like tutorials and Medium posts and stuff, that sounds familiar. But yeah, a lot of the stuff, frankly, the network stuff, a lot of like biology has done that stuff. And then I just found a couple parody accounts. The way this actually all started was trying to build a bot that only made thought leadership, and it's still out there. But anyway, yeah, where I got a lot of sort of just the code and ideas from were from like parody accounts, to be perfectly honest. But that's a fantastic use case, and I'm sure there's some pretty advanced. There's money in it, right? So, yeah. All right. Any other questions?
Thanks, man. Great talk. I'm not sure if I missed when you said about the NLP, if you're doing something similar to sentiment analysis for feature extraction.
Like in the problem statement?
For instance, you could use as a feature like a list of bad wording that you give a score to, and that could be a feature for removing like people that don't use the keywords like DLL or brute force or I don't know what. So it could be maybe, I don't know, an idea of a feature as well.
Yeah, that's a great idea. I'm doing something kind of like that, but probably not. It's not super advanced. It's pretty basic. I basically made just doing statistical analysis of the data set and just like a correlations and co-occurrence essentially, made a list of keywords like exploit, bypass, things like that are just kind of helpful in differentiating, sort of red team stuff in many cases, or stuff like Yara. I mean, that's a nice low-hanging fruit keyword. So there's definitely more to be done there, but yeah. Sort of getting in that direction, but I haven't really over-scienced it too much.
Hey, I was just thinking about some possibilities for features, and I was wondering what your thoughts are. I know you mentioned that you didn't want to include things that have a time lag because you want to be able to classify sort of in real time. I was wondering about possibly using like time-lagged outputs later to get some extra weak labels out of what you're seeing. So like, since your team probably doesn't have time to look at everything that the model's scoring, you could use things like replies as like a weak labeling mechanism. And then also I was thinking about all the ones that are based on follower count and friend count and things like that. Now that you're iteratively developing this network, like subsets of those that are maybe given more weight or something, people from the network.
Absolutely. The whole like personalized PageRank thing, there's definitely, just from this conference, so many things I've written down in my notebook already to improve the graph is completely vanilla, like naive. So there's a lot to do in that space. As far as the weak labeling, I was desperate to find a way to label these things better. So I kept looking for easy signals that I could get from the, because you're absolutely right, using the reactions would be a great way to label a data set. It was frustrating because people replied all sorts of stuff. And I found, I'd say generally, but not in a way that I could really draw hard lines. I found that retweeting and quoting tended to correlate better with what I was looking for, but also just not in every case, and it certainly didn't separate the classes close enough for me. But other approaches like what Phil just presented might be something we could incorporate. And that's absolutely, I think, something we plan to do is use those reactions to try and improve our labeling. I'll also add that like human labeling is super noisy. It's great to ask my teammates, but we all have different takes on what we find useful for different reasons. So even on a small team, it's hard to communicate a uniform grading mechanism. So I'd much rather find something a bit more dynamic and scalable like that.
All right, do we have any more questions? All right, let's thank our speaker.
Thanks.